Hello everyone and welcome back. So I'm gonna try to explain the issue quickly. And let's say we have a grid and we have points. So this is our current position. We are sending this information to the render. Okay, we're going to apply displacement and it's going to become like this. So those 4 points will be, for example, like this. And whatever data we have, whatever information we have available, now that position has moved. Okay, so what we need to do is we need to get the new position here, the current position after displacement, and use this. Let's call this P1 and this is P0. What we need to do is we need to use this position P1 and query information from the original mesh. Okay, so at render time we need to get the new position and use it to query data from the old mesh. Unfortunately, we don't have that mesh. Nowhere in any engine we will be able to access that data. So even if we have new point position, we're not going to be able to go back and get me the information that was in this space. Now that information that we want is called UV, and no engine gives you access, no render engine gives you access to query attributes based on position. If you want to query something based on a position, you need to do a point cloud lookup. Now point cloud lookups are only available in Mentra, and this means that we will provide the engine with two things. One is PTC data, which is a point cloud representation of the mesh that doesn't get displaced. So it will be points that are available that we can read at render time. And then two, the geo, which we will displace at render time. So after we change the positions of this, we use that new location and say, okay, I'm happy with this position. Please go back to the original mesh and get me the information. Now, it's not that simple, because if we take a look here, I'm going to try and explain the problem as best as I can. So, okay, so let's say we have this mesh. Let me turn off the color. Okay, so let's say we have this mesh, and then we transformed it. We moved the point positions. So let's say 1 point. We move this point like this. Come on. So we moved that position. We can take this location and say, okay, that position, I want to go back and query this mesh. So we take that position and we do a lookup on the original mesh. This works great with Mentra because we can provide that point cloud, and whenever we're in a different space, we can go back and say, get me the position of, get me the information at this space. But the problem is we're not in this state. We're not in this frame. At some point, we're going to be like this. We're going to be like this. So now we've taken this point and we've displaced it. This new position doesn't mean anything to the original data if we don't know where this point is. So what we need to do is we need to get the rest information. We need to store this original position as an attribute in the mesh, and then after we transform it, when we go in the render, we say, okay, this is the position. I don't care about that. I want to get it where it was originally in the scene, and that's going to be stored as an attribute. Now, because the points are being displaced, that attribute moves with them. Okay, so we get this information and say, okay, where did you come from? And we find where it is. Now, the problem with this is that it's not going to be correct, because what we need to do is take that position, that entire mesh, and apply the inverse transformation of our matrix. So this, because after we do this transformation, after we do the displacement at render time, we cannot use the rest position anymore because it's different. So we need to take the render time position, apply an inverse transformation to it, which is to negate any RBD movements, and then use that to query at render time, use that new position to query the point cloud. All this is very, very complicated to do, and it requires us sending matrices to render. I've tried so many things with the open shading language to do the same thing, with Arnold to shoot rays into a different mesh and do lookups and things like that. I got some stuff to work, but it's nowhere near stable. And I'm going to offer a solution that works with any engine. The only downside is, well, it's not a downside, but the only problem is it's going to have a heavier mesh. And it is perfectly fine to have a heavier mesh. Now, why is that? Well, when we displace the geometry, either Arnold, Redshift, or anything that doesn't have a rays algorithm, it's not a micro polygon like Mantra, the geometry is going to be high res. Whether we provide it to the render or we subdivide at render time, the memory usage is going to be the same. So what if we can do this? What if we can fix all the UVs issue and only have a high res mesh that is going to be used for rendering? So we do all our sim perfectly fine, and then when we are ready, we take that geometry, apply our edge displacement into the scene, and then create something that is high res. So let's say these are 4 polygons. We're going to subdivide them in the scene, apply our displacement to move everything the way we want it, and then fix the UV and only provide a scene at render time. Only send that geometry at render time. Now, the issue is, the problem with this is if we have 10 million polygons and we're going to apply the transformation and cache it every frame, it's going to be a nightmare for us to work with. So what we need to do is we need to either use packed primitives, which works great with Mantra because it only stores the initial mesh 1 frame and then it applies the transformation. So it's going to be easy. We don't have to cache the high-res geometry, but we cannot do this with Arnold because we don't have a way. In Redshift, it supports packed primitive, so it works. And with Arnold, it also supports packed primitive, but it's not very efficient. So what we're going to take a look at probably next week is how to store a high-res mesh and apply only the transformation at render time using Arnold. This is something very, very new that they've added. And this way, it doesn't matter where the high-res geometry is going to come from, whether it's at render time or in the scene. We're not going to pay different memory usage. We're not going to be paying a huge overhead. So in the next, I hope this clarifies the problem about the UV space. In the next video, I'm going to show how we can fix this and have a geometry that is ready to render without any issues. Thank you guys for watching, and see you in a bit.